Hi, my name is Chris Gibson, and I'm the lead developer on GLASS, Divestco's Seismic Interpretation workstation. And today I want to walk you through building a time-to-depth model using our gridding tools, and then I want to give you a peek at something we've been working on, a new tool to bring together these time and depth surfaces and use them to take our seismic data from the time domain and bring it into the depth domain. Now there's a few steps along the way, and here's a brief look at the overall process. First, we need to ensure that some basic information is set. Then we're going to interpret our seismic data and pick a few surfaces as required. We need to associate those horizons to various formation tops in the well database. Using those picked horizons, we're going to generate some time grids. Using those same horizons and the associated formation tops, we're going to generate some depth grids. And after repeating this process for the rest of our surfaces in the project, we're going to bring it all together and convert our time domain seismic to the depth domain. So let's get started. This is the Blackfoot 3D dataset that was shot just east of Calgary as part of the cruise project, and I'm going to use this as our demo project. First, we need to ensure that the project datum is set correctly. Under the File menu, we have Project Properties, and we can ensure that we have set the datum as required, in this case 1,000 meters. Next, we want to make sure that we have some formation tops loaded. So looking at a particular well, we can see that there is a selection of tops available for us for this process. Then we're going to interpret our seismic data. So taking a look at our time domain seismic here, you can see that I have in fact interpreted a few surfaces. And of particular interest, let's take a look at this bottom surface here that I have called the basement. Posting that on the map, we can see our raw picks for the entire surface. Now, to get a better result, I found that smoothing the surface prior to the process gives a better result. So I'm going to throw a 9x9 smoother on here. And I'm going to save that as a new horizon, as I'm going to need it in a few places. All right. Now we need to associate our horizon to a formation top. To associate horizons to formation tops, we once again go to the File menu, and under Associate Tops, I select the horizon I wish to associate, which in this case is the smoothed horizon I've just generated, and I'm going to associate that to the basement formation in the well database. And that's all I need to do there. If I post that elevation, I can see that I do in fact have the basement picked on several of the wells. And in this case, I've actually tried for a flat surface at 1,300 meters below sea level, or 2,300 meters below the project datum. Now we can go ahead and generate the grids. So we start by making sure that we do have our horizon posted that we want to grid. And we're going to go ahead and generate a time grid. In this case, I want to use the 3D as the geometry for the time grid. I want to generate time, and I'm going to go ahead and create a basement time grid. Once that process is completed, we'll post the basement time grid. Now, I need to go back to our original horizon, and I need to generate a depth grid for it. In this case, once again, want to use the 3D geometry as a thing, but I'm going to generate a depth grid. This brings the formation top and the time together, generates a velocity grid, and uses that velocity to propagate with the time through the rest of the 3D to generate a depth to that horizon. So once again, creating the grid, I'm going to call this basement depth and go ahead and generate that. Now, this is not exact because it is interpolated in between, and using velocities and various times, it does have slight differences, but it's plus or minus 25 meters, which is close enough for what we're doing here. Then we would go ahead and repeat that process for the other surfaces I've got in the database. And I can see that I have, in fact, generated several other depths for several other horizons and picks. Okay, now we can go ahead and do our time to depth conversion. We start by displaying the seismic time section that we wish to convert. And we fire up the process from the processing menu and selecting time to depth. On the left-hand side, we have our time grids that are available. In the right-hand column, we have our depth grid. All we need to do is associate the time grid with the associated depth grid, and the order is not important. It will take care of that for us. So we just click as necessary, the Viking to the Viking, Manville to the Manville, Glauconetic to the Glauconetic, and there's our basement that we've just generated. After setting our maximum depth, what sample rate we want, we can go ahead and actually create the converted seismic. This uses as many processors as you have available in your machine in a multi-threaded environment, so the more processors, the faster it's going to go. And once that process is complete, we can display our depth seismic data by selecting that version from our versions. And there you have it. There is our depth converted seismic as we've wanted. I hope these tools will be something that you can use, and we look forward to providing further information about glass. Thanks for watching.